So if you're just joining us, we're just finishing up part 2 of 7.1, number 43, navigation problem. To figure out the bearing from Elgin to Canton, law of cosines, we're going to cross multiply. So basically just going to multiply both sides by 500. So 500 times the sine of 46. Well, sine of C is equal to 500 times the sine of 46 degrees all over 720. So the sine of angle C is equal to 0.499541528. So to solve for angle C, we do the inverse sine of 0.499541528. And that gives us an angle of 29.967237 degrees. And so this angle right here, Destiny, in the back, what are they rounding to?
Open.
What was it?
I don't have the book open.
Oh, then I got it.
Okay.
Nearest hundredth. So the nearest hundredth, 29.95 degrees.
0.7? 97? Isn't it the 6 go up?
Oh, shoot. Why did I see 5? Okay, yeah. 7. Thank you. Okay. Now, just to make sure we have everything squared away, the other possible answer, and so just so you can see how this relates to the last question we did, the other possible answer would be quadrant 2. So we just got basically 29.97, quadrant 1. So quadrant 2 would be 180 minus 29.97. So that's a 150.03 degrees. So now you have, it's 46. It's 46. Could you put 150 together with 46 and make a triangle? No. So that's why this is not a 2 triangle case. That makes sense?
Mm-hmm.
Okay. So every time, just in case, there's 2 possible answers for that angle, this time there's only 1 triangle. Just like, most of the times only 1 triangle. So now you know that this angle is 29.97 and 46. So we got 29.97 and 46 degrees. So we got 9,7, 15, carry the 1. So that was going to be 75.97. So angle E, the angle in the triangle, not the answer yet. just the angle in the triangle. 180 minus 75.97 degrees is going to be a 3. That's going to be a 0. That's going to be a 4. And that's going to be a 104. In the triangle, this is 104.03 degrees. But that's just the angle in the triangle. Okay? You know that this angle, the 46 that I put here, is just this part of the alternate interior. So my little red part up there, 180 minus 46 is going to be 134. You see where I'm getting at?
Mm-hmm.
So the bearing, the actual bearing now, you put it all together. From north is this 134 degrees, and then the angle in the triangle of 104.03. So 238.03 degrees. It's imperative you draw the picture. And like I said, on your test, I'm only going to give you the bearings and the directions. You have to draw the picture from the words. Now they have 240.03. Unless I read the wrong column. They have 240. Did I make a mistake in my calculations here? I don't want to take time trying to fix it now. That's 134. Oh, there's my mistake. There's my mistake. Alternate interior angles. 46 is not the alternate interior. The alternate interior. 44 there. This is 44 here.
Okay.
So if that's 44, that means this is 138. Or sorry, 136. And if that's 136 on the outside, what am I thinking? That's going to change this on the inside here. basically I'm going to gain 2 degrees here. I'm also going to gain 2 degrees here. So that's going to, or sorry, I'm not going to gain 2. I'm gaining 2 degrees, and that's going to bump me up to 240.03. I'm gaining 2 whole degrees because now that's 44, so that's 136, so that's right. Okay. Okay. All right. What's next?
On 7.2, I don't know if it's a typo, but on number 15, it gives you angle A, side B, and side C, but the answers give you angle A.
Yeah, so that would be a typo because that would have to have been angle B
Mm-hmm.
and angle C. Did you come up with B equal to 29.44?
I solved for side A, and that's where I stopped because that's when
Okay.
I checked the answers.
Okay, so I bet angle B is that actual answer.
Okay.
But yeah, it is a typo because they can't tell you angle A is 50 in the question and then change it to 29 point something.
Yeah, that's where
That's
I thought I was looking at the wrong chapter, but no.
Yeah. You said you had all the way to 25?
Mm-hmm.
Well, that was going to be like my next example, I think. So let's go there.
Okay.
How's it going, Jose? So it says complete the table by solving the parallelogram shown in the figure. it says the length of the diagonals are C and D. So when they label this C, they're talking about this entire length. That is C, and this is D. So on 25, fill in the table. A, B, C, D, theta, and phi, or phi. A is 4, B is 8, theta is 30 degrees. All right then. Sometimes when you have as messy a complicated picture as we have right here, it's going to pay off for you to separate what you're looking at. We have A, B, and theta. A, B, and this whole angle theta, which means we have this triangle that comprises the left side or the left corner of the parallelogram. We have this triangle right here. In that little triangle that I just pulled out of that parallelogram, what is this opposite side labeled?
D.
It's the D. And what we have so far is that this is 30. This is equal to 8. And this is equal to 4. So that's enough information to figure out angle D and to figure out some other pieces. And I'll tell you how we're going to get the rest of it in a second. But right now, enough to figure out D, law of cosines. Law of cosines in any triangle, side angle side, the opposite side squared. In this picture, D squared is going to equal A squared plus B squared minus 2 times AB cosine of the included angle theta. So D squared is equal to 4 squared plus 8 squared minus 2 times 4 times 8 times the cosine of 30 degrees. So D squared is 16 plus 64 minus 2 times 4 is 8. 8 times 8 is 64. The cosine of 30 is square root 3 over 2. Anytime you're given our special angles, I would always use exact value. We can always convert it to decimal when we need to. So D squared is equal to 16 and 64 is 80 minus 2 goes into 64 32 times. 32 square root 3. And then here's what people forget to do. This is what people forget to do. They forget to take the square root of both sides because that's what d squared equals. So then you take the square root of both sides, and the length of that side d is the square root of 80 minus 32 square root 3. Now I'm sure in the back of the book it's going to be a decimal. I just want to make sure I know what they're rounding to. 7.2, number 25. They round to the nearest hundredth. So 32 times the square root of 3. And then take that away from 80. So we're taking that on the inside is the square root of 24.5743 7416, and then take the square root of that. And we get D is 4.95 725 47. So to the nearest hundredth, 4.96. Okay, so that's D. If I want to find C, this is the triangle C is a part of. Now, the real good news, I do know what A is. A is still 4. B is still an 8. Because according to the rules of parallelograms, opposite sides are congruent. So if this is A, that's an A. If this is B, opposite over here is also B. But in order to find C, I need to know angle phi. Or maybe it's pronounced phi. I wish I knew. Then again, I didn't join a frat. So, in parallelograms, when you reach deep down into the heart of your geometry, in a parallelogram, definition, both pairs of opposite sides are parallel. That's the definition of parallelogram, which means lots of things end up happening. Opposite pairs of segments are congruent. The opposite sides are congruent. Opposite angles are congruent. Those two angles are congruent, and these two angles are congruent. But there's something about consecutive angles. There's something about angle A, angle B, connected. There's something about B and C. There's something about C and D and A. There's a connection between these two angles. When we did what?
Are they at 180?
Exactly. Same side interior angles are supplementary. If two angles are on the same side of the transversal of parallel lines, then those two angles must be supplementary. That's 180. So therefore, when theta is 30 degrees, phi is 150 degrees. There we go. And now we can do law of cosines for angle C, or for side C. So C squared is equal to 4 squared plus 8 squared minus 2 times 4 times 8 times the cosine of 150 degrees. C squared equals 16 plus 64 minus 2 times 8 times 8, so 64. Again, here we've got to be careful. The cosine of 150. Negative square root 3 over 2. If the angle is obtuse, that means the angle is in quadrant 2. And if the angle is in quadrant 2, cosine is going to be negative, which means the next step, C squared is going to be 80 plus 32 square root 3. The last one we had was 80 minus 32 square root 3. This one's plus. And if you don't get your signs right, that's where the biggest mistake happens. So now we end up taking, don't forget to take your square root. So C squared is going to equal the square root on the inside. (32 times the square root of 3, and then add 80 to that. And then take the square root. So this is going to be the square root of 135.4256.258. And then you take its square root. Don't forget, that's the biggest mistake. Been a big mistake. And we get C is equal to 11.63725.164 to the nearest hundredth, 11.64. And we already found this was 150 degrees. There we go. So it's not so bad. But just, it really helps when you pull the parallelogram apart and work it as two separate and see the two separated triangles versus trying to work it while it's in this mess. There's nobody says you can't do this. I also want to do number 37. Okay, on 37, the first question is, determine whether the law of sines or the law of cosines can be used to find another measure of the triangle, then solve the triangle. So just by, taking, a short inventory of what you have two angles and a side. If you have two angles and a side, that's not law of cosines. Law of cosines is for side, angle, side. So you have to have two sides and the included angle. This is two angles and a side. So this is definitely not law of cosine, side, angle, side. Or law of cosines works if you have side, side, side. If you have three sides, you can find the missing angle, one of the missing angles. So since you have two angles in one side, this is a law of sines problem. Without even drawing a picture, I know it's going to be a law of sines problem. Basically, process of elimination. It cannot be law of cosines. Because law of cosines is side, angle, side, two sides in one angle, or side, side, side. So we just want to draw a triangle. It's got two acute angles. Technically, I know the third one. On your test, you're going to solve the triangle A, B, C, and find the three side lengths. Since you're given and have to be given three pieces of the information, half of the problem is already done for you. 42 degrees, 35 degrees, 1.2, whatever units it might be in. If you're given two angles, you better at least find the third angle. So that adds up to 77 degrees. So 180 minus 77 degrees is 103 degrees. The missing angle is 103 degrees. So now we have 4 out of the possible 6 pieces done. But it really helps to put things in the right places if you draw a triangle. It really does. It's going to be an obtuse triangle. And I prefer to draw an obtuse triangle with my obtuse angle down here. Now 103 is not that wide. If it really does help to draw a little bit to scale. If this is 90, then 100 is just 10 degrees past 90, and 103 wouldn't be that much further. 103 would be like maybe right about here. That might be 103 degrees. Let me see. Would you look at that? There's 100 degrees, and I drew it right there between the 103 and 104 by freehand. Not a single ooh. You guys are muted. Not a single ooh or ah. Not even in the chat. But that'll help get something to scale. So there's angle C. And then once you drew that nice 103 degree angle, don't mislabel it. You just blew the whole problem. That's your angle C. And then you got two acute angles. Now, they're pretty close in measurement, so it really doesn't matter which one A or B is because they're pretty close. A, 42 degrees, B, 35 degrees. So there's little a, there's little b, little c, 1.2. Law of sines. Sine of c over 1.2. You need an angle and an opposite side to set up one ratio. The sine of c over c is equal to the sine. Let's just go in order. A over a. So the sine of 103 over 1.2 equals the sine of 42 over little a. As I showed you in the earlier lecture today, in the 204 lecture that'll be up online, you cross multiply, so it's going to be a times the sine of 103, 1.2 times the sine of 42, but since you're solving for a times the sine of 103, you're now going to divide both sides by the sine of 103 degrees. So the length of A is going to equal 1.2 times the sine of 42 all over, you'll end up dividing by the sine of 103. I have to see at least this. If you don't show me all the decimals on your paper, that's fine. But I at least need to see your cross multiplication, how you're setting it up before you put it in your calculator, so I know you at least wrote it down properly. That way, if there's any partial credit to be had, you might get something if you plugged it into your calculator incorrectly. If I don't see this, then I have no idea what you did. And at least if you show me this, at least I know that you knew that A was set up correctly. Maybe I have fat fingers, I punch wrong buttons. 1.2 times the sine of 42, and then divide by the sine of 103. So A is equal to one big common mistake is they'll go 1.2 times the sine of 42 and then divide by 103 and forget to hit the sine of 103. And students will write down whatever's in their calculator. That's what my calculator said. Well, you got to also think about what your calculator is saying and not just always trust what your calculator says. Your calculator is always right. Your calculator will always give you the correct answer to what you put in. The question is, did you put in the correct information? I have A equals 0.8240777,879. And so far, they have been rounding to the nearest hundredth. So this would be 0.82. Now, that's 1.2, and the angle A is smaller than 103. So this side better be smaller than 1.2, and it is. So that's okay. So far, everything's looking okay. And then you got to do the same thing and solve for angle B. The sine of angle B over B is equal to the sine of angle C over C. Don't use angle A and the side of A that you just found. Always use what you know is exact. So the sine of 103 over 1.2 equals a sine of 35 degrees over B. And we cross multiply. So B is equal to 1.2 times the sine of 35 divided by the sine of 103. that gets punched in. We get B is equal to 0.706 3966233, and to the nearest hundredth, B is equal to 0.71. So over here, angle B is the smallest angle. 0.71 is the shortest side. So everything, the longest side is opposite the biggest angle. The smallest side is opposite the smallest angle. Everything looks like it's supposed to be, 0.71. Hurry up, Lando, go. Lando, let's go. That was 37. Nafisa, did I actually do 41? Do you remember if I did 41, Nafisa? Oh. Nafisa, do you remember if I did 41 or not? I think I did. It was Heron's formula. She might have walked away, but I believe I did. Yeah, I did. I see it now. I remember those numbers. So, bottom line is, I'm basically on the chapter 7 test going to ask you a couple of homework questions from 7.1 and 7.2. I'll be more specific on Monday, but a couple of questions from 7.1 and 7.2. And then the bonus questions will be more like from the old tests. More like the old tests, like the last test that we just took. The very last question, the very, very last question of the old test, where you were given sine and a cosine of triangles, of angles in different quadrants, and you had to do the sum angle and difference or double angle formula or whatever. I'm not going to make you do 6 of them, but maybe 2 of them as a bonus question, or maybe something else from the first test. You never know. Those types of bonus questions, something that kind of get your mind thinking about everything we've done so far. And they're just bonus questions, so everything you get is just gravy. And the people who are choosing to do the option 2, where you get to take it later on in the day, but not on Zoom, there are no bonus questions on that. No bonus questions at all. It's just you and the test It'll be different problems, of course, but no bonus questions. And the reason why it's a longer time frame is because people get off work at different times. So I wanted to have a larger window to accommodate people who might be off work at different times, but not so long that people would have a huge amount of time versus the people who were actually doing it, you know, in real time in the morning. And the people who choose to do it in the morning, you get the bonus questions as that incentive. And again, as I wrote in that email last night, the final will be done at our regularly scheduled, it actually is at 9 o'clock, not 9:30. It starts at 9 o'clock on May 20th. From 9 o'clock to 10:50. Now I see a chat.
Do we have access to the formulas on this next test?
It's all open note. You can have everything out you want.
Okay.
Yes.
So why are you keeping our cameras on for this test?
Is there anybody else in the room? You know, are you watching video? Are you watching, like, you know, Khan Academy do problems for you?
Oh, okay.
You know, those kinds of things.
So you want us to just use our notes? We couldn't be watching a video. Like we couldn't be
You
watching
can watch videos of me. You are more than
that's
welcome to watch, you know, our class videos. That's fine.
Okay.
But when we say it's you and only you, the inconsistencies that I tend to seeing is I was seeing people's tests and answers with answers that were basically identical from one test to another. It's like somebody was just passing around the same answers to the same test, and they were wrong. So it's like, wow, these were all the same wrong answers going around. What's up with that?
Oh, okay. I understand.
And so with the cameras on, it's a little, you know, that gives me that little bit of more peace of mind for me. And I hate that. I really do. But anyway, yeah, navigation problem. You got it. So let's look. 7.2. You want to just do 49? No, that's 7 point, yeah. What is home? Where's my page? Yeah, do you want to do 49? Okay, I see the chicken. Yep. Okay, 7.249. On a map, Minneapolis is 165 millimeters due west of Albany. Phoenix is 216 millimeters from Minneapolis, and Phoenix is 368 millimeters from Albany. find the bearing of Minneapolis from Phoenix, and then find the bearing of Albany from Phoenix. Okay, so like I said, test question, this would not be given to you with a picture. You have to translate these words into your own picture. So you got to pick a place to start. The first place I'm going to start, it says, on a map, Minneapolis is 165 millimeters due west of Albany. So hopefully you know a compass heading. North, east, south, and west. So if it's due west on a piece of paper, I'm probably going to want to start over on the right side so I can go left, which is west. So Minneapolis is due west of Albany. So I'm starting at Albany, which is A. And I'm just going to put a little compass, and I'm going due west. Having a straight edge is not a bad idea. And you're just going to go 165 millimeters to the west. Straight line, horizontal, to the west. And that's when you get to Minneapolis, which I am not going to spell, just going to put M. But when you get to Minneapolis, you're going to have another compass heading, because we're going to go somewhere else. Phoenix is 216 millimeters from Minneapolis. Now, hopefully you know that Phoenix is in the southwest. That Phoenix is a little bit towards Mexico. And that Minneapolis, Minnesota, and Albany, New York are in the northern part of the United States. Hopefully you know that. And that Phoenix is in Arizona, and Arizona is in the southwest over here by California and Mexico. Hopefully you know that. So hopefully you know that at least we're going to be heading somewhere over here. Now it says 216 millimeters. Now 216 versus 165. 216 is longer than 165. In fact, 216 is about 1.5, maybe even 1 2/3 times, but at least 1.5. So you might want to make it 1.5 times that. So if I made that, I should have made it exactly 1 foot is what I should have done. I made that, it looks like 10 inches. So I'm going to make this one 15 inches, just to give me some perspective. Some kind of perspective. So 15 inches. Right there. And here's Phoenix. And then you'd have a compass heading here. But then here's that Phoenix to Albany. Completing your triangle. And having a straight edge makes a difference. And Phoenix is 368 millimeters from Albany. This is 165 millimeters And this was 216 millimeters. Okay. Now look at what I drew. Does it actually look like the 165 is shorter than the 216, which is shorter than the 368? Yeah. Does it look like the angle opposite 368 is bigger than the other two angles in the triangle? Yeah. When you draw your angle as close to scale, your triangles as close to scale, and your headings as close to scale as you possibly can, when you do your calculations, the numbers won't play tricks on you. If you don't draw to scale, these numbers can play tricks on you. They really can. If you would have put Phoenix over here, then that 216 and that 368 don't look like they're the one's longer than the other. Okay. We are supposed to find the bearing of Minneapolis from Phoenix. Of Minneapolis from Phoenix. So starting from Phoenix, we want the bearing from Phoenix to, we want this guy right here. This is A, question A. What is that bearing? And then part B, find the bearing of Albany from Phoenix. So how do I get to Albany? What heading would I take to fly to Albany from Phoenix? So part B is, what is this heading? That's part B. Understand what questions they're asking of you. They want the bearing of Albany, of Minneapolis from Phoenix. So starting from Phoenix, what heading, what bearing would we take? So starting at north, how far would we turn? So that's A. And starting from north, how far will we turn to go to Phoenix? Which means we're going to need to know what this angle P, and we're going to call this vertex right here. This is vertex P right here in the triangle. We're probably going to need to know M and A. We're going to need to know some pieces here. So let's do it. If you have three sides in a triangle, the law of cosines will give us some angles. It looks like we're going to need angle P. Definitely. And it looks like we're going to need one more angle. We're going to need at least two angles in that triangle. So, angle P. These numbers are going to get big. 165 squared is equal to side angle side, 216 squared plus 368 squared minus 2 times 216 times 368 times the cosine of angle P. So 165 squared, 27,225 equals 216 squared is 46,656 plus 368 squared is 135,424 minus 2 times 216 times 368. 158,976 cosine angle P. Remember, we're solving for angle P. So that means we're going to take inverse cosine at some point. So 27,225 equals, add these two together. That's 182,080. Minus 158,976 cosine angle P. And now you subtract 182,080 from both sides. That gives us negative 154,855 equal to, don't forget the negative, negative 158,976 cosine angle P. Divide both sides by negative 158,976. And the cosine of angle P is equal to a positive 0.9740 778 482. And then you take inverse cosine of 0.9740778 Remember, you don't round until the end. And that's going to be your angle P. Angle P comes out to equal 13.074 22032 degrees. So when you round, we get 13.07 degrees, and that's the angle in the triangle. That's just this angle, 13.07 degrees. Realize what you need. The answer to angle A is basically the answer to angle B, take away the 13.07 degrees. And or, if you actually can take a look at this as well, the answer to angle A is alternate interior angles with this one right here. That and here are alternate interior. So if you can figure out that part, you have your answer to angle A. And if you know what angle A is, then you know the exterior piece for part B, and then angle B is just that exterior piece plus 13.07 degrees. So the bottom line is, in order to finish this up, we absolutely have to have 13.07 because that's the only way to finish up the answer to part B. But we also need this exterior piece. And that exterior piece is the alternate interior to that piece. Well, that piece right there is just, if I call this theta, that exterior piece right there, is just my answer to A, or I'm all confused now. I just have to go, whatever that angle M is, theta is equal to M minus 90 degrees. The piece that I want is vertex M, and you take away 90 degrees, because that's your 90 right there. It's a puzzle. You just found that piece of the puzzle. How do you get to these other two pieces? Well, that piece is alternate interior to that one. So you got to figure out that guy over there. That's why you need these little compass headings, so you can see how they fit together. So now, law of sines. You could do law of cosines again. You could do law of cosines and figure out all of angle M. But since you know this angle, you can do law of sines, because law of sines sets up a little quicker, and law of sines to figure out vertex M. But when I set up law of sines, don't round. The sine of angle M over opposite the 368 is going to equal the sine of angle P over its opposite, the 165. So the sine of angle M, which is what I'm trying to figure out, over 368 is equal to the sine of angle P, and I'm going to use the sine of all of that. Don't round. It's in your calculator, so you can still access it. 13.07422032 degrees over 165. Multiply both sides by 365. So the sine of angle M is equal to 365 times the sine of 13.07422032 degrees over 165. We get the sine of angle M equal to 0.5004106,942. So that means we have inverse sine, or angle M is equal to the inverse sine of 0.5004106,942. And so the measure of angle M is 30 point. And then, great question. I like this one. Look at this. Angle M is equal to 30.0271753 degrees. All right. Okay. I see that. Okay. Great question. When you're dealing with these triangles, it's going to be in degrees. Because when we're doing headings, it's going to be in degrees. So it's, when you look at how the problem is written, it will have to be given with an angle in degrees. If there's no unit on the angle, then that's radians. So if the question said, what is the cosine of 37 degrees, obviously that's degrees. If it said, what is the sine of 4 degrees, obviously that's degrees. But if it said, what is the sine of just a 4? If it said, what's the sine of 4 with no unit on it, that's in radians. When there's no unit, that's a radian question. So you need to be able to remember, if there's no degree symbol, that's a radian that you're taking the sine of. But whenever we do measurements of triangles and solve triangles, when we solve triangles, angles are in degrees. Okay. Is it possible in my picture that this angle right here, the whole thing from ear to ear is just 30.03 degrees? That's why having a picture, so you can put it in the place there and see whether or not, does this make sense? Does that make sense?
Yes.
This whole angle is 30 degrees. Angle M, the whole thing, opposite the 368. Because when you think about it, if this is 13 and that's 30, they add up to 43. If this adds up to 43, then angle A has to be 137. Can angle A be the 137 if that's a 216 and that's a 368? Is this making sense?
Repeat the question.
So when you do the inverse sine gives you 30 degrees. That's what your calculator is going to say. But look at the picture. If I say that this angle M, the whole angle right here, opposite, is 30, and that's 13. Together they make 43. If that's 43, then that's like 136. Can angle A be 136 when this is 216 and that's 30 opposite 368?
No.
No. So think about, what is the alternate answer? Sine is positive in two quadrants. You got your 30.03 here, and you got a 30.03 here. Sine could also have been 180 minus 30.03, 149.97. That makes more sense. Angle M, the whole thing is 149.97 degrees in that triangle. Because it's obtuse. Look at our picture. It's obtuse. So now, remember what we were after. We wanted theta so we could get the answer to A. Theta was just m minus 90. So theta right here is just 149.97, take away 90 degrees. And that's 59.97 degrees. So this is 90 on that side. This is 59.97 over here. So right here is 59.97. So what's the bearing of Minneapolis from Phoenix? Part A. From Minneapolis to Phoenix, the bearing is 59.97 degrees. Turn 59.97 degrees and you're headed towards Minneapolis. And then for part B, to go from Phoenix to Albany, it's just an extra 13.07 degrees of a turn. That angle is 59.97. Inside the triangle is another 13.07. So that's 73.04 degrees. The whole turn would be 73.04 degrees. To go from Phoenix to Albany. So this is what happens if you don't think. If you would have just used 30, 90 minus 30 would have given you a negative angle. So hopefully you figured it out by then. Okay. If you have any requests for Monday, any problems that you want to see done, again, I will send out invites for this 8:30 lab session. I'll be glad to do, if you want to request them ahead of time, send me numbers, send me problems. And then I'll send out the invites for the 9:30 session. And then the test, like I said, make sure people who are watching at home, tell me which option you want to do. Do you want to do it live at 9:30? Or do you want to do it later on in the day? Option 2, check your emails. But if you have problems specifically that you want to see done, let me know. You guys have a good weekend. And for those of you that are moms, happy Mother's Day. And for those of you that, have moms, make sure you take care of them.
Thank you.
You're welcome, you guys.
Thank you.